Dear M1 students, AS or A-level students, hi, and I wish you the best all and everywhere again. We are in the second part of momentums. We covered the first part in the previous video about momentum 1, and we did define what is the momentum and what is the impulse momentum principle. Today we'll be studying the motion when the two particles collide, collision problems. Problems involve collision. Mainly we'll be using today a law, that is conservation of momentums, the principle of conservation of momentum. When two particles or particles collide, dear students, or impact, when they collide, each one of the particles act on the other one by equal force in magnitude, equal in magnitude, but in opposite direction, And the same for impulse as well. And the same for impulse. Each one of the two particles will be exerting an equal magnitude of impulse, but in opposite direction. Now, because the impulse of each particle is equal, so the momentum in the whole system, in the whole motion with the two particles collide in the collision, will be cancelling themselves out or each other out. So we'll say in simple language, the momentum will be unchanged, like shown here. I'll be explained. I did explain here in the diagram. This is the impulse by M1 on M2, and this in different or opposite direction for M1. So I have the same magnitude but opposite direction. So now I calculate this, that is called, it's called the principle of conservation of momentum. That is a law, as a formula. Total momentum before collision, before the particles collide, is equal to the total momentum after collision, after the particles collide. Now this is a main diagram to start with. It's not necessary these velocities and this diagram and this information in this diagram always for the questions. Will be told the directions of velocities and impulses in the question, according to the question. Just we start to explain to you. So for example, these two particles collide in the same direction in this diagram. U1, we mean by U1, it's the speed or velocity of the first particle before collision. U2 is the velocity of the second particle before the collision. V1, it is the velocity of the first particle after collision, and V2 is the velocity of the second. So in simple way, M1, since total momentum is equal to M1 times U1 plus the momentum of the second particle is equal to the momentum after the collision, after they collide, M1 V1 plus M2 V2. When we do the problems now, I choose only today to do past paper problems on this topic, different types of questions. The most important thing when we start doing the examples now, or the problems, stating the direction, showing the examiner the direction, dear students. You will understand by the examples now. I started with question number 1, June 2012. The question says, first example, two particles of masses A, which has mass of 5 m kilograms, and the second particle B of mass 2 m kilograms, are moving in opposite direction, in an opposite direction. The particles collide directly. Immediately before the collision, the speeds of A and B are, so the speed of A is 3, the speed of B is 4 meters per second. This is the mean by respectively, so 3 and 4. The direction of motion of A is unchanged. Look, we are given everything in the question. Immediately after the collision, the speed of A is 0.8 meters per second. Find in part A the speed of B immediately after the collision. Part B, once in the collision, the magnitude of impulse exerted on A by B is 3.3 Newton second. Find the value of M. Part B, find the value of M. Before I start calculating or writing the formulas, sketch the diagram, draw the diagram of the given information. So this is particle A, 5m, this is particle B, so that I in both, by each particle, the other one is I in opposite directions. We are given the question, the velocity or the speeds, they moved opposite directions. So the U1, the speed or the velocity of the particle before collision was 3 meters per second, opposite direction. So show, like I did, I'm doing now in another color to show you what's happening. It was 4 meters per second. And you are given the velocity after the collision of particle A is 0.8 meters per second. Why in this direction? Because the question said unchanged. So this is the direction I started with, or the particle started with, so you keep the same direction. About after the collision for particle B, we don't know, we calculate. Since we are given A and B, it's more convenient, more consistent to write, instead of writing M1, U1, and so on, write MA UA plus MB UB is equal to MA VA plus MB VB. It's more clear to yourself and to the examiner himself. Only that I will do here to find the velocity of B. He wants the speed of B, of particle 2. Writing the formula, then replacing, considering, my dear students, the direction. So I stated, it's up to you, but more convenient to start with the particle you stated in the diagram, making sense even in this direction. So this is the positive direction that we are following. So any velocity in this direction, it will be positive. Any speed or impulse, any quantity, vector, opposite to this direction, we'll put it as negative. This is the idea in this lesson. So the particle of MA has 5m kilograms times 3 with positive, plus 2m times negative 4. Here it says negative 4. Because he said opposite direction. Look. So this is the positive direction, this is the opposite one. Is equal to 5m times 0.8, which is given in the question, in the same direction as well because it's unchanged, plus 2m times VB, by calculating 15 times 3, 15, 2 times negative 4 is negative 8 times m cancelling each other from both sides. Solve this equation for VB. The speed of the particle B or particle 2 is 1.5 meters per second. In part B, we are free, dear students. But to follow what does he want exactly, he said, find the impulse or calculate exerted on A by B. So this is the direction that we are, this one, 4B, impulse 4B. So the impulse 4B is equal to mass of B times V of B minus U of B. Impulse momentum principle. which is in the previous video. So just you're replacing the quantities given the information. The mass of the particle B is 2m, 1.5 that we had just found, which is the particle, the speed of the particle after the collision. This is the mean by VB, minus 4, dear students. Be careful to the signs. Is equal to the impulse, 3.3. Why? Because V now, it's positive after we found it. It was positive, so it's in this direction. Since UB from the beginning is opposing UA, so it's opposing VB as well in the same direction. So it will be 2m times 1.5 minus, which is plus 4. So it's 2m times 5.5 is equal to 3.3. By calculating for m, you will get the mass is 0.3 kilograms. This is almost straightforward question. Let's move forward to a different type of examples or problems. This question, dear students, is question 3 on January in 2009. Two particles A and B are moving along the same horizontal line. Particle A with mass km kilograms, and the particle of B is m kilograms. And he told me that K is more than 2, less than 3, is greater than 2 and less than 3. But in opposite directions. They collide directly. Immediately before they collide, the speed of A is 2u meter per second. The speed of B is 4u meter per second. As a result of collision, the speed of A is halved and its direction of motion is reversed. Look, we are told everything in details. Find in terms of K and U the speed of B immediately after the collision. He reminded us here again where K is more greater than 2, less than 3. Part B, state whether the direction of motion of B changes as a result of collision. After the collision, he means explain your answer. If it does change, explain your answer. Part C, given that K is equal to 7 over 3, find in terms of M and U the magnitude of the impulse that A exerts on B in the collision. Good. Before we start, as we said in the first question, draw the diagram, the information, draw the motion, draw. So, this is particle A with the speed 2u, opposing particle B with the speed 4u. And he said, look, he said, before the collision, it was 2u, it's half of 2u, which is u now, and it's reversed. So you show this. The best way to not confuse yourself and the examiners, show them the directions are changed or reversed. V we don't know yet. After we calculate, we'll know by writing the formula or the principle of conservation of momentums. MA UA plus MB UB is equal to MA VA plus MB VB. By replacing the quantities given, Km times 2U plus M times negative 4U. Be careful pay attention to the signs. Let's listen about signs as well. If you write the signs and the quantities correctly, you get the answer easily. Even the question looks weird or challenging. Is equal to Km particle A times negative U because it's reversed. It was this direction, it is this direction, plus MB times V. Particle M, the mass of particle M is M times VB, which is V. By factorizing both sides for M, so M with M cancelling each other's, minus ku, move it to the other side, it will be 3ku minus 4u is equal to v. So vb, the velocity or the speed after the collision for particle B is 3ku minus 4u meter per second. Part B, we have to focus here. Based on what I can justify that particle B will change its direction or not? Because it's in terms of variables. By using the given information, dear students, this is the idea in these parts, or these questions. By writing V is equal to U, just put U as a common factor times 3k minus 4. Since he told us in the question k is greater than 2, my dear students, k is greater than 2. So this part, 3 times a number greater than 2, it will be greater than 6. So this number is greater than 6. Minus 4. So the result here, the value here, will be positive. Because this is more than 6, this is 4. So it will be positive. 6 minus 4 is positive. So this means that V is positive. V greater than 0. So V is positive. Good. What does this tell us? So this is the direction with positive. Based on this, dear students, the particle, the direction that I started with, it's opposing its initial speed or before the collision. So this is the speed of particle B before, it is now in this direction. So you will say the direction of B after the collision will change. This is the justification. This is, he means that explain your answer. Part C, by using the value of k is equal to 7 over 3, find the impulse. We are free, we said. Previous example, we took the impulse for B. We'll take it here for A. So this is the direction of impulse for A. So I is equal to the particle, the mass of particle A times VA minus UA. So I is equal to Km, the particle, the mass of the particle A, Km, times U, VA is U, minus negative or minus 2U. Minus 2U. This is the direction that we are in now. So 2U in this direction. So I put it with negative. So Km, K by replacing, substituting K by its value 7 over 3M. U minus 2U, it's 3U. So 3 with 3 gone. So the impulse that he is asking for, I is equal to 7 mu Newton second. Even the question or the results or the answers are in terms. But look, when you consider the direction right, write the quantities, draw the diagram, you'll be getting the answer easily. Last question for today, which is 2018 IAL, the last syllabus, IAL, International Advanced Level, question 3. Question says two particles A and B of mass 2m and km respectively. Particles are moving in opposite directions along the same straight horizontal line so that they collide directly. Immediately before the collision, A has the speed 2u and B has the speed u. Direction of motion of each particle is reversed. Is reversed by the collision. Immediately after the collision, the speed of A is u over 2. Find the magnitude in part A of the impulse exerted by B on A. Part B, look how the way they ask sometimes. Show that K less than 5. Show that most of times, dear students, in the exams, the questions on momentums or colleges, they come almost straightforward, except some questions. So I did choose them to you. I did select last two problems for you to be familiar with the different types of questions. We'll be starting by part A. Step number 1, draw the diagram. So this is the speed 2u of particle A. He told us, and this is particle B, opposite direction. He told us for both or each particles, the velocity or the speed is reversed. So he wants now the impulse. We are free. We can start with calculating the impulse on A or for A. I is equal to ma VA minus UA 2m, which is the particle of A is 2m, while u over 2 minus negative, be careful, negative 2u, because they are in opposite directions. So u2 plus 2u, it's 5u over 2 times 2m. So the impulse that he's asking about is 5mu. Look at the previous question. He said in terms of m and u. He doesn't need to say. So some students, even many of us, unfortunately, they think when we say find the magnitude or calculate, our answers must be constant numbers. This is not true. Not true. It is constant, but the values of m and u are not given. So we found this is the magnitude of the impulse, 5mu. Now using the same value of impulse for B, you'll be showing his question. Since the impulse is equal, this is the fact. This is the application of conservation of momentum principle. This is the principle here. We put the impulse for particle B, 5mu is equal to mass of B, VB minus UB. What you'll be getting now? So 5mu is equal to km. The mass of the particle B is equal to VB, which is V, minus u. Minus from the law, negative u, because it's opposing the direction that we are following here. This is the direction of the impulse for B here. This is the direction of the impulse. So negative u, it's opposing this direction. So you put it negative. Getting by cancelling m from both sides, 5u is equal to k times v plus u. Making v the subject, you'll be getting v is equal to 5u over k minus u. Easy as AS or level students algebraic work. Okay, since v is positive, dear students, v is positive. Yeah, v is positive. How do you know? Because he said the directions reversed, and this is now the direction of v, which is in the direction of the impulse that we are applying. So v is in the positive direction. This means that this part is positive as well. This is the idea in these parts, like or such these questions. So this implies that 5u over k minus u is greater than 0. By adding u to the other side, 5u over k greater than u with u cancelling each other's. So 5 over k greater than 1. This gives or implies at the end k less than 5 that he wants from us to prove or to show. We'll be solving soon some selected questions when you do full past papers on momentums, but these are like the most common ones, like they are different questions on this topic. We'll be taking after this, starting with moments, then vectors to finish the syllabus for the students. Will be having now predicted grades in this international or Middle East. I don't know the zones now. What did Excel will decide. At the same time, if they delay the exams to October session, you'll be ready. So I recommend and advise you to follow the videos, communicate if you need help, subscribe the channel and ask questions if you don't understand. As usual, wishing you the best.